Have you ever wondered what secrets lie beneath the surfaces of the planets in our solar system? What if I told you that some of these worlds aren't as lifeless as they seem? From hidden oceans beneath icy crusts to vast magma seas beneath molten exteriors, planets may be hiding more than we ever imagined. Could there be life in these extreme environments? What if the most fascinating discoveries are waiting deep below the surface? Stick around as we uncover the mysterious secret worlds hidden inside planets and explore the potential for life beyond what we know. What do you think we'll find? Subsurface oceans. When we think about the possibility of life beyond Earth, we often imagine distant planets with Earth-like atmospheres and vast oceans. But what if the oceans we're searching for are hidden beneath layers of ice, far away from the harsh conditions of space? Surprisingly, many moons in our solar system, including Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, are believed to possess subsurface oceans, hidden deep beneath their icy crusts. These oceans remain in liquid form thanks to tidal heating, a fascinating process where the gravitational forces of their parent planets cause the moons to flex and stretch, generating enough internal heat to keep the water from freezing. The more we learn about these subsurface oceans, the more it seems that they may be the best places to search for alien life. After all, liquid water is one of the key ingredients for life as we know it. The existence of these hidden seas raises intriguing possibilities. Could there be microorganisms lurking in the dark waters beneath the ice, thriving in an environment where sunlight never reaches? Perhaps these oceans are the last frontier for life beyond Earth, a place where evolution could unfold in ways we never expected. Scientists are already planning missions to explore these moons further, using advanced technology to penetrate their icy surfaces and uncover the mysteries of these hidden worlds. Who knows what we'll find deep beneath the frozen crusts of Europa or Enceladus? The search for extraterrestrial life may just be closer than we think. Magma Oceans. Imagine a time when planets were nothing like the solid, stable worlds we know today. Instead, they were fiery, molten bodies, a chaotic, blazing hellscape where the entire surface was covered by a seething ocean of magma. This magma ocean phase was a crucial part of the early formation of many planets, including Earth. When planets first formed, their interiors were so hot that the surface remained in a liquid state, with vast global seas of molten rock. Over time, these molten layers began to cool and solidify, forming the planet's crust, while deeper layers continued to remain liquid or semi-liquid, eventually giving rise to the core and mantle structure we observe today. But why is this important? The magma ocean phase is not just a fascinating snapshot of planetary youth, it provides critical insights into how planets evolve over time. The cooling rate of these magma oceans, the composition of the minerals trapped within them, and the chemical reactions that took place during this phase can help scientists understand the history and development of planets, including our own Earth. It's also the key to understanding how Earth's atmosphere and oceans eventually formed, making this molten past essential for understanding the building blocks of life. So next time you think of a planet, remember that it may have once been a giant ball of fire, a world in the midst of its chaotic birth, a world that over billions of years slowly transformed into the planet we know today. Cryovolcanoes. Imagine a volcano erupting not with molten rock but with water, ammonia, or methane. This might sound like something out of a sci-fi movie, but in fact, it's happening right now on other planets and moons in our solar system. These so-called cryovolcanoes or cold volcanoes are found on celestial bodies like Enceladus, Saturn's moon, and Ceres, the dwarf planet. Unlike Earth's volcanoes, which spew lava and ash, cryovolcanoes eject icy substances from beneath the surface. Beneath the frozen exteriors of these moons there are hidden oceans or liquid reservoirs that, under the right pressure, can forcefully erupt, pushing out water, ammonia, or methane in violent bursts. This unusual activity hints at a dynamic and active internal structure beneath the icy crust, and it suggests that these moons are far from dead, frozen worlds. In fact, cryovolcanism might play a crucial role in shaping their landscapes. The eruptions could refresh the surface with new materials, creating geyser-like features that dot these distant worlds. The discovery of these cryovolcanoes isn't just fascinating from a geological perspective, it also has huge implications for the search for extraterrestrial life. These eruptions could be providing nutrients and energy to subsurface oceans, creating environments where microbes might thrive. The thought that such dynamic processes could exist on a frozen moon challenges our understanding of what conditions might support life. It makes you wonder, are these icy moons hiding even more secrets beneath their frozen exteriors? Subsurface life. When we think of life beyond Earth, we often envision distant planets with lush green landscapes or vast oceans teeming with strange creatures. But what if life is hiding in a place we wouldn't expect? Beneath the icy crusts of distant moons, in the dark, crushing depths of their subsurface oceans. On moons like Europa, Enceladus, and even Mars, scientists believe that life could be thriving far below the surface, in environments we once thought impossible for living organisms. The key to this possibility lies in the presence of liquid water, a vital ingredient for life. Beneath the frozen surfaces of moons like Europa and Enceladus, massive subsurface oceans exist, kept warm by internal heating mechanisms such as tidal forces. These oceans could harbor microbial life, isolated from the harsh conditions of space, yet still alive and active in the depths. This concept of subsurface life is a game changer. We've always looked for life in places that resemble Earth, but these underground hidden worlds could have life forms unlike anything we've encountered. The search for life could no longer be limited to the surface of planets and moons, but extend deep beneath the crusts of these icy worlds. Imagine beneath the ice there could be vast ecosystems of microbes, thriving in the darkness, fueled by the heat and chemicals from the planet's interior. If life can exist under such extreme conditions, it raises new questions about the resilience of life and where else in the universe it could be hiding. Could there be life on planets and moons we once thought uninhabitable? The mystery of subsurface life is one of the most exciting frontiers in astrobiology. Planetary magnetic fields. Imagine standing on the surface of a planet, feeling a strange force around you, a protective shield that deflects harmful radiation and solar winds. This invisible force is the planet's magnetic field, and it plays a crucial role in shaping the planet's environment both on the surface and deep inside. Planets like Earth, Mercury, and Jupiter have powerful magnetic fields generated by the motion of molten metals in their cores. These fields act like giant shields, protecting the planet from the constant bombardment of cosmic radiation and solar particles. Without this magnetic barrier, a planet's atmosphere could be stripped away, leaving the surface exposed to the harsh elements of space. The magnetic field doesn't just protect, it also influences the internal structure of the planet. The motion of conductive materials in the planet's core generates the field, creating a dynamo effect that helps drive geological activity. On Earth, this dynamic process has been critical in sustaining life, as the magnetic field has helped preserve the atmosphere and the conditions needed for life to thrive. Understanding planetary magnetic fields can also tell us a lot about a planet's age and evolution. For example, the fact that Earth's magnetic field has been stable for billions of years suggests a well-developed internal structure, while the lack of a magnetic field on Mars could explain the planet's inability to retain a thick atmosphere. As we explore distant worlds, studying their magnetic fields can help us understand how they formed, how their environments have evolved, and whether they might be capable of supporting life. Water-rich cores. Water, it's the most essential ingredient for life, but where is it hiding on distant planets? Most of us assume that water exists only on the surface of planets in oceans, lakes, and rivers. But recent research suggests that a significant amount of a planet's water may actually be trapped deep within its core and mantle, hidden from view. This discovery challenges previous models of planetary water distribution and opens up new possibilities for understanding the composition and evolution of planets. For example, scientists have found evidence that Earth's mantle contains a huge reservoir of water, far more than exists in all of the world's oceans combined. While it may not be in liquid form on the surface, this water exists as part of the minerals and rocks that make up the mantle. The implications are vast. If other planets and moons have similar water-rich interiors, it could mean that the total amount of water in the universe is much greater than we've ever realized. It also raises the intriguing possibility that water may exist on planets where we wouldn't expect it, deep inside, hidden beneath layers of rock and metal. This discovery also sheds light on the processes that shape a planet's geology and climate. Water deep inside a planet could influence volcanic activity, plate tectonics, and even the generation of magnetic fields. As scientists continue to study these hidden water reservoirs, it could change how we think about planetary formation and the potential for life in places we once thought were too dry or inhospitable. Thanks for exploring the hidden worlds inside planets with us today. The universe is full of mysteries, and who knows what groundbreaking discoveries await us. If you enjoyed this journey into the unknown, don't forget to like, share, and subscribe to Space Facts for more mind-blowing content. What other secrets do you think space might be hiding? Drop your thoughts in the comments below, and let's keep the conversation going. See you in the next adventure.